One of the things that the Unconventional Fuels Task Force said is there are an estimated 1.2 trillion barrels of oil in the states of Utah, Wyoming, and Colorado trapped in oil shale. Well, out of that 1.2 trillion, we estimate that we could extract about 800 billion barrels of oil. Okay, remember Canada, 170 billion barrels, Saudi Arabia, 260 billion barrels, the United States, 800 billion barrels. I argue that today, if our government came out and said, we are going to move to develop our unconventional resources, even if they just focused on oil shale, that there would be a dramatic impact on oil prices today. Because one of the drivers of oil prices is what's happening long term. People are entering into long-term contracts, and there's no risk of entering into those contracts because they expect there to continue to be this tight demand and supply situation. You introduce the potential for 800 billion barrels on the market, there is definitely going to be an impact because that trumps all other known reserves for oil. So I want to point out that all of these things I've mentioned and shown you in pictures can be read in the Unconventional Fuels Task Force report. We produced an incredibly thorough report that has all of this information on it. It's hundreds and hundreds of pages, so you can use it as paperweights, read it online, or a nice offset on your bookshelf. But there also happens to be a set of fact sheets that accompany this report. I encourage you to go to this website and look at this. It'll talk to you. It talks about the availability of this resource, the location of the unconventional resources, and what the real potential is for the United States to secure a better place for its energy future. Now, if we have the resource, and I'm up here telling you we can develop it, how do we know? Well, the reason that we know is because there are technologies out there that have already been proven to work to convert this resource, oil shale, tar sands, coal to liquids, I'll say the whole spectrum, into oil. Recently, subsequent to the task force report, the DOE did a report on the technologies available for the extraction of oil from oil shale and tar sands. And they reviewed 27 different technologies. And Red Leaf's technology, the EcoShell technology, was included in that report. These were viewed as technologies that were proven to work. DOE came out in a public presentation and said of all of the technologies that we reviewed, we think that there are 3 that are most likely to go to commercial scale the soonest. One of them was ExxonMobil's modified in situ process. One of them was Royal Dutch Shell's process. The other one was Red Leaf Resources' EcoShell process. These were deemed to be highly economic and highly environmentally responsible. So what does our technology look like? Just very quickly, we call it an in-capsule recovery and reclamation process, and I'll explain it to you pretty quickly. Essentially, this works best with surface mining, although it can work with other types of deeper resource as well. But essentially what we do is we mine the resource out of my little light's not, there it goes. We mine the resource, so we go in and excavate an impound, and we would set the shale off to the side. We set the overburden off to the side. We go in then and we line this with an impermeable barrier, and our patent covers a variety of opportunities for putting in that impermeable barrier, different products. I'll tell you that this impermeable barrier is consistent with what they use to contain things like coal slurries or uranium tailings, so it's a proven technology for that. Once we've done that, we go in and we insert metal pipes into the impound, and then we replace the shale. And it's a fairly deliberative process. You put in the pipes, you put in the shale, then pipes, and then shale. Then we put the impermeable barrier over the top, and we actually replace the overburden. We then bring in gas-fired heaters that heat the pipe to roast effectively this heap that's in here. It takes about 90 days to roast. Once it's completed, we've extracted the majority of kerogen out of the shale that's in there. And one of the other things that we've done, because we're going to heat slowly and at low temperatures, we haven't decomposed the rock. If any of you are familiar with oil shale issues of the past, people said, well, what are you going to do with all those leftover tailings? And what if there are contaminants and those types of things? Well, we have done tests on our depleted shale that remains remains, and we don't find any hazardous characteristics at all. But a couple of things that are important to note is, one, because we don't decompose the rock, the cementatious quality of the rock is retained, then that means that all of those metals, those additional metals that are contained in the rock, won't be leached out. So that's important. But we also go this extra step and put this impermeable barrier, which will contain the tailings over time. So we roast and contain our tailings in the same area, and so we don't have to move the rock again. One little thing I want to show you about this little puff over here, so that you don't think that this is some type of pollution. This is actually, our process is perfectly amenable to carbon capture and sequestration. Because we use natural gas-fired burners, there are technologies available. They are not economic today, where you can capture the carbon. It's called oxy-firing, and you would heat this essentially with pure oxygen, pull the carbon out before you even do the heating, sequester that carbon, capture that carbon, and then there is an opportunity to sequester that carbon. And in fact, our patent covers opportunities for carbon capture and sequestration. So this is just another side view of what our process looks like. If you're wondering, well, where does the oil come out? It comes out in two places. Down here we have collection pipes. As we start heating the rock, some of the oil is going to start to come out in the form of a liquid. It'll come out through these drainage pipes. We'll then pump that into storage tanks. But as the heat increases in the capsule, it will begin to vaporize, and we will collect the additional product up here with condensers, and then we will also pump that into storage tanks on site. So we have two products. One is called a prompt liquid, which is what comes out the bottom, and then we have what's called a condensate, which comes out the top. We have found that by heating the rock very, very slowly, that we get an incredibly high quality product. Right now, when you look at oil prices and you talk about what the price of oil is, they're pricing that off of mid-Texas intermediate crude. That's about where the price is coming from. The quality of that crude is about a 34 to 36 API. That's just the American Petroleum Institute's gravity weighting. Our oil is coming out of our process at 35 to 40 API. So it is a very, very high quality sweet crude product. In fact, if you look at it, it looks clear. It has a little bit of a red tint because it's got a little bit of nitrogen in it, but it comes out, and you could read through it if you wanted to. Very high quality product that you can use to produce jet fuel, naphtha for gasoline, and also very importantly for the production of diesel, and in particular low emission diesel fuels. So this is just kind of a summary of the aspects of our project. It is economic because of it's all civilly engineered. It's also environmental. It protects surface water, protects aquifers, has reduced CO2. We can also amenable to carbon capture and sequestration. And the big deal on the economics, not just the construction cost or the capital cost are low, this high quality API is critical. Historically, when oil shale was produced in the 80s, they were really heating the rock at very high temperatures, getting a very low quality product, or a much lower quality product, about a 19 API. Well, that's half the quality of what's being sold on the market. If you're selling half the quality product, you're going to get half the price. If you can break through that, then you can solve the economics, which is what we've done. One of the things that we're going to demonstrate is our ability to rapidly reclaim the area. On 1 acre, you can produce 5 barrels of oil equivalent ethanol, 5 barrels. On 1 acre, you can produce 10,000 barrels of conventional oil. On 1 acre, you can produce 100,000 to 1 million barrels of oil equivalent kerogen from oil shale. So compare that, 5 barrels to 100,000 if you go with the low end. So that means lower disturbance, less environmental impact, smaller footprint. There are opportunities to develop this in a very economically and environmentally friendly way. And moreover, I think it can be a fundamental part of how we meet our energy demands in this country, and we do it the right way. Better energy security, which means better economic security, and long-term energy and environmental sustainability. So thank you.